welcome to Sambine's webinar, The Future of Network Optimization. We could have easily called this webinar how to make better decisions and get the right data to make those decisions. So let's jump into it. Before I jump into Sambine's solution or what the problem that we're going to tackle today is, I want to first start talking about what are the major headwinds that are happening on the telco side in today's economy. One of the things we are seeing today is that most network operators are actually spending less and less money in the last 2-3 years. And the ones that are spending more or are still spending are the ones trying to finish deployments in 5G networks. But overall, what we are seeing is that telco providers are reducing their cost. That's mainly driven by pressure on their P&L, and mainly because of all these OTT providers still are, succeeding in the network, doing a good job about their own business, and creating a lot of traffic and pressure on telcos to provide this throughput or traffic in the network. So if you put this together and you layer on top of it the uncertainty in the economy and how the macroeconomic environment is making telcos be more careful about their spending, we have a good mix of prioritizing what money do you spend in the network today. So telcos need to be smarter about this spending. But the problem is you as a telco have this challenge, which are two opposing forces. On the left side, you're trying to minimize these capacity investments in the network. We saw in the previous slide the reasons why. But when you do that, you actually hurt the experience of the subscriber significantly. On the other side, if you try to maximize the subscriber experience in your network, it's costing you a lot of money to do that in today's environment. So these are opposing forces that you have to deal with every single day, and it's the real challenge of network optimizations in today's environment. So let's think about network optimization and the typical plan or cycle to optimize networks today. First, you get data from the network and you make plans about it. You apply policies on the network, whatever the policies may be, and then you spend money to optimize the network. Now, the challenge is that the underlying information we believe is inaccurate or sometimes even missing key information to make these decisions. Because of this, the policies are flawed or not optimized to do a great job about it. And then because of that, the investment decisions are not maximized. So you are overspending in the network. Now, let's look at the triggers of this decision-making and these policies that you are using in the network today. Telcos today are doing things like using throughput as a trigger, or they're targeting heavy users that use a lot of the capacity in the network to minimize these capacity investments. Or they're using quota-based plans, where you try to also create these quotas on subscribers so that they don't use all the capacity in the network as much as they want. Or finally, creating static policies. What are the challenges of all these approaches? All these approaches are manual by design, and they need to be analyzed, monitored, and even retuned over time because network conditions are changing. So it's actually very difficult to maintain these policies, make these policies become very effective in the network, and requires a lot of effort and time and money on the operator side. Now, we actually believe there is plenty of room in the network still, but these policies, what they're doing is they're leaving bandwidth behind. They are inefficient in the resource allocation. And I'll give you an example. When you look at targeting heavy users, typically, you do this managing users based on the volume they consume over a whole month. And then for users that consume a lot of volume, you might create some policies to target them and make sure that you limit how much traffic they use. The goal of this is to improve the experience of other users or to reduce congestion during congestion time. But as you can see, what the user does over a period of a month does not necessarily relate to how you spend money in the network today. How do you spend money today in the network is based on congestion time. When there is congestion, you have to do something. So when you're targeting these heavy users, you're targeting them because of what they do over a period of month. But during congestion time, which is the most important time to do something about it, they are not necessarily involved in the congestion. You could have a heavy user that is heavy because of their usage in the morning, when there is no traffic in the network or in the middle of the night. Does not mean that they are using that capacity during congestion time. So this is what we mean by an efficient resource allocation. You are targeting them, you're trying to save bandwidth and improve experience of users, but by default of these policies, they are not very efficient. They don't happen when it's most needed. And we believe part of this is because you have inaccurate understanding of your data, or you are lacking the right data to make the right decisions. So you end up with this, you end up with the same problem that we talked before. You have to either take care of the quality of experience of your subscribers, or you end up overspending. I like to call this, instead of service providers trying to spend money just in time, they're actually spending money just in case. So the tendency is actually overspending, and we believe there is a better way to do this. So what do you do? I want to bring two ideas that are key for what do you do in the network. The first idea is that you need to understand what's going on in your network. I want to show you an example of these two nodes or these two links on the left side. One is a residential area where most of the traffic is actually video, 70%, and then you have some gaming and some browsing, and that's what's going on in this node. Then on the bottom one, you have a business area, and in this business area, now the traffic is video conference, web browsing, and other traffic. So you see that the traffic is different in both environments, and as you see there, the throughput per user on the top one is actually, let's say, 5 megabits per second. And the throughput on the bottom one is 4 megabits per second, but the traffic is different, right? And not all traffic requires throughput in the same way. As you can see on a residential area using video, throughput is very important. But if you look at the business area, throughput is less important. It's more important things like latency. If you have a lot of web browsing, you don't need as much throughput to have a good quality of experience. So this is a good example how you could have two nodes with different, let's say, throughput per user, and at the same time, the experience could be actually the same. It doesn't have to be driven by throughput. So this is what we mean by understanding what is happening in your network. You need to understand what type of traffic is in the network, when that traffic is happening, during peak time, during congestion, or in the middle of the night when nobody cares, and how it is impacting your network. So this is the first idea. The second idea is that maybe there is a better approach of how we do today, we make these decisions. And this is using AppQoE as an approach, or using a throughput or volume-based approach. If I elaborate on the same example, today when you have a node like this, you make decisions based on throughput, on certain throughput threshold. Let's say this node needs to be upgraded when the threshold goes below 4 megabits per second, right? Or 5 megabits per second, as the example before. According with this measurement, you could end up thinking, okay, I need to upgrade this node a year from now, because this is when I'm going to reach my threshold based on throughput. But there might be a better way to do it, because what if instead of using throughput, you use the experience of what's happening in that node? As we saw before, the throughputs were different. In the previous example, the residential area had a throughput of 5 megabits per second, and this one a throughput of 4 megabits per second. So it looks like this node is doing much worse. But if you look at the score, actually, it could be doing better, right? It could be doing the same or even better. So this is what we mean by changing how you make decisions. Instead of focusing just on throughput, which is actually driven by video, and it's a very specific application, obviously is the most predominant application in the network, so it's very important. But you're always going to have certain amount of nodes that are using other applications that are not so driven by throughput. And then the quality of experience actually matters a lot. And the end result is that using this quality of experience as a threshold can allow you to defer when do you have to invest money on those nodes in certain nodes. Right? That's the goal of changing your approach. Instead of using throughput, maybe we should be using quality of experience. Now, this is actually a proven solution. We have a customer in Peru that using these technologies, and AppQoE actually was able to defer their CapEx by 2 years in their own words, and we'll discuss more about it later on. So you actually have more room than you think today. What we are saying here on our message is, if you do proper allocation of resources in the network, you make decisions based on AppQoE, you can actually better optimize the network, and you can have happier customers at the same time. So how this is done? Someone is here to build your decision intelligence. That's what we're here to help. And that's what Sunbind AppQoE company is all about. We're here to help you, service providers, complement your decisions that today are maybe based on throughput and volume and traditional KPIs, with an application-centric view. That's what AppQoE is about. Now, if you look at how users use your network today, this is how it looks like. You have a family with people using applications during the day. Everybody's using their own applications. But this is actually how operators see the network today. They're not able to understand what those users are utilizing. On top of that, they have limited network KPIs to make those decisions, right? As we discussed before, you typically use things like throughput and latency, but you have a blurred visibility on what's actually going on in the network. So what that means is that there is no customer point of view in your decision making. Now, imagine if you could actually map those metrics that you use today, like throughput and jitter and latency and packet loss, into actually what customers feel like. Imagine that you could actually understand what applications every subscriber is using. Layer on top of that, when are they using it? What access technologies are they coming from? Where are they located? And even some contextual awareness. So what type of subscriber this subscriber is. Is it a roaming subscriber? Is it a heavy subscriber? Is this a subscriber that is actually suffering right now in the network? And then you could map all that to the devices they're actually using and create a score for each of these applications. If you could do this, you could actually determine how customers really feel, understanding the subscriber quality of experience. And this is what AppQoE is all about. AppQoE is the world's first true real-time depiction of customer satisfaction. Now, let's jump into why AppQoE is important. If you look on the left side, this is all the things that as a network operator you care about and you work every day. You have to plan your network, you have to fix your network, you have to preserve the capacity on your network or secure it or support it or even grow it. So what is AppQoE doing? AppQoE is unlocking better decision making on all these aspects. And how does it do it? Because it provides information that is critical to all these areas. So for instance, for planning, you can do application usage. What are the application growth trends? What is the application performance and quality of experience of those applications? What are the outliers and vulnerabilities and usage and segmentation? So all these aspects, which is the application-centric point of view, actually help in all the areas in a service provider. So we hope that you take this message to your colleagues in the network operator, and you communicate how AppQoE actually can help all of them. For the sake of time in today's webinar, I'm going to focus on just two of them, the planning and the preserving, where we're talking about network optimization and capacity planning. Now, how does it look, AppQoE, right? AppQoE is a score that goes between 1 to 5 to score the experience of the user or the application. And the idea is that instead of having disk, a network-centric view where you only see a pipe with some KPI metrics, you can actually get this. You can get a view where you can classify different segments of your network based on application and access technology and users into how customers are actually feeling. This score of 1 to 5 is represented here, and you can segment it over applications and network access and many other things. And what is that going to accomplish? It's going to accomplish that those opposing forces that we discussed at the beginning, now they're aligned, right? Now we can actually minimize capacity investments and at the same time maximize subscriber quality of experience. Why we can do this? Because we're bringing you the subscriber experience part of it that you didn't have. Before, when you were making capacity investment decisions, you were basing everything on throughput, right, as a metric. But by doing that, you are overspending or you are underspending. Here we give you both a view of the experience that customers are using and the ability to make those decisions based on experience, which is also going to help you defer some capacity. So that's what we mean by we can align both. Now we look at the network optimization cycle workflow. Now it looks a lot better because we give you application-based accuracy. So now the data is more accurate and you have data that you didn't have before. Now we can make better policy decisions, and we'll look into those in the next few slides. And because of that, we can actually optimize your investments. Now, let's look at the first two, the planning and apply policies, and let's look into Sunvine portfolio. If you look at network optimization solutions in Sunvine, they're bucketed in two areas. One of them is the capacity planning area, and the other ones are focused on the congestion management solutions based on AppQoE. Now, we'll talk briefly today at the end of this session about the planning insights, a new product that we launched last year and we are enhancing in 2024. But today we're going to focus mostly on the network congestion management solutions. There are two types of it. The more traditional ones are the static and dynamic policies, where we have fair usage congestion management, heavy user management, and video streaming management. And then we have an area with the new use cases on Sunvine portfolio, which are more focused on the automation and automated policies. Here we have TCP optimization and intent-based congestion management. Now let's focus on the network congestion management solutions. And let's focus on the static and dynamic solutions, the ones that Sunvine has for quite some time. If we look into the first one, fair usage and congestion management, this use case is about making decisions based on time of the day, location, and applying shaping policies based on tier and tier subscribers to reduce congestion. The uniqueness of Sunvine is that actually we can apply use traffic classification on top of it, and that's what makes this use case unique to Sunvine. A good example of how our customers are actually using is like the customer I mentioned before. This customer in Peru has a very interesting story, probably shared by most operators around the world. During the pandemic, there was a huge traffic growth, right? And then a lot of the network nodes were heavily congested, which led to a lot of complaints from customers and churn. This customer came to Sunvine looking for solutions, and we were able to apply policies based on like Zoom and Teams to actually defer CapEx for up to 2 years. So this was the outcome that the operator actually communicated to us. Just by doing these policies, simple fair usage congestion management, but focus on the application side, they were able to make those savings. Now, the second use case is heavy user management. This is a traditional use case as well, where network operators focus on understanding how much volume of traffic every subscriber is using and then applying policies on top. The uniqueness of Sunvine is actually we can layer on top, again, the application classification and the application QoE-centric point of view. How this is reflected in the outcomes of subscribers, so I'll give you another example. In South America, we have another mobile network operator, and their story is a little bit different from the previous one. This was more on the operation side, and they needed to control the bandwidth in the network. But more importantly, they also needed to comply with some regulatory rules, right? And now, what was the approach that we took with this customer? We actually helped them make this a reality. We identify certain type of traffic and we group them together to create policies that were able to follow these regulatory rules of the country, but at the same time manage those heavy users in the network. The outcome is we could save bandwidth in the network while at the same time improving the quality of experience of users. Now, lastly, I want to talk about video streaming management. This use case is also very interesting and very unique to Sunvine. Here, we can actually get information, quality of experience KPIs, as like video stalls and start times and video streaming health. Even the video resolution are KPIs we can actually infer and detect in the network, and we can create policies about this. The reason why this is important is because you want to create policies where, for example, people are not using ultra high definition video during congestion time or at peak time. Or maybe they are watching a video on a small phone. It's not needed that they're using ultra high definition. So you can apply policies that save bandwidth in the network heavily, just managing how this video is actually played and when it's played and by the users and the quality that they have. Now, I'm going to focus in the automated policies. We have two, as I said, TCP optimization and intent-based congestion management. For sake of time, I'm going to focus today on the intent-based congestion management, which is one of our newer use cases. This use case is an evolution of all the static and dynamic policies that we have today. Now, let's look into intent-based congestion management. Imagine that you have your network is split like this in different segments, where each segment is split by applications and access technology, and you have an application like fixed wireless access gaming that is actually suffering. Imagine that you can create certain thresholds, and this is what we mean by intent-based congestion management, the intent. Intent is defined by two arrows that you see there, the red arrow and the green arrow. The red arrow represents the minimum quality of experience we want in certain applications or like segments that we have created in the network. And then the green one is the target. The idea here is we want to create a range where we are allowed to make changes in those type of traffics based on like the business intent. So if I want to prioritize, let's say video, like in this example, you see that the range is higher than the range I have for fixed wireless access, but it's still a range. You can play around with this range. The idea of intent-based congestion management is that if you see one segment where it's suffering, but you have others that actually are doing pretty good when you look at it from like the application quality of experience, you can actually reallocate resources. And these resources that are like good, but like maybe not necessary or mandatory during congestion time, you can reallocate them and make sure that most of your applications are actually doing good and are doing good based on your business intent, the intention that you have in the network. And this is what intent-based congestion management is all about. The key part is that it's an automated algorithm, is quality of experience based, and the goal is to, at the same time that we can detect congestion in real time, the idea is to apply these policies when is needed the most during congestion time and where is needed. If you compare it with traditional use cases, those use cases were good and they work, but they work sometimes like protecting bandwidth, but also hurting the experience that users are having in the network. In this case, IBCM, or intent-based congestion management, is more focused. It just acts or applies policy only when is needed and where is needed, only when you need it. And it's all based and automatically done based on this intention, which aligns with your business objectives. This is important because it's not always about like saving bandwidth. It's not always about giving the best experience of users. You have priorities. And now you can define these priorities based on the intent, based on your business goals. A good example of this is like maybe you're launching fixed wireless access, right? But you also want to protect the mobile users. Something we have seen very common is that once operators launch fixed wireless access, they realize that they're damaging sometimes the mobile users. So this is a good way to actually, still launch those services, but protect those users according with the business intent and doing it in an automatic way. Remember, a lot of the use cases before were all manual. They need like a lot of people and interaction and analysis and retuning. This only needs to set up the intent of the business. What is the innovation behind this intent decision-making? So two things. First of all, this algorithm can detect congestion on real time. This is critical because this is when the algorithm is going to take effect. And it's using these multidimensional intent categories. We're able to mix network information, so what is the access technology, what is the subscriber type, if it's suffering or not suffering, if it's a heavy user or roaming, and the link upstream, downstream, and obviously the application type, to create these segments that you see on the right side, sorry. You see, on the right side, you can create segments based on video only, that's application driven, or heavy user video. This is combining application plus subscriber information. Or you could do fixed wireless access social traffic. This is combining network information and application. The idea is give you the flexibility to create those segments as you wish and as many as you want, and create the intent based on those. So now let's look into the planning part. And this is just a teaser. We'll probably talk about this in a much more detail later in a different webinar. This is a new product launched last year and that we're enhancing in 2024. The goal of planning insights is to get all these bubbles that you see on the right side, right? Like planning as a solution exists today, and it uses things like network APIs, network access technology, network links, what is the time of the day, the location, and some subscriber information. And it's using all this information to provide, let's say, predictions about when do you need capacity, what's going on in your network. So what is the innovation that someone is bringing with AppQoE? It's actually bringing innovation in these two areas. On the network APIs, it's not only about throughput and latency, we're adding also the quality of experience KPI as a much more advanced KPI as we have seen in this presentation. The second one is on the application side. We can give you the application view, what's happening, and not only the application vendor, but also what is the content, like video, category, etc. This is what AppQoE brings, from Sandbank. This is very unique. And then there is some new parts on the subscriber side. As of today, people talk about heavy users as a label, but sometimes it's difficult to kind of like measure what heavy user is, and the definition varies by operator. What we are doing in the subscriber area is we are taking an approach that is more data science way, and we create this classification of subscriber segments based on like medium and standard deviation. So we can create default buckets where we say normal users are between 1 and 2, between +1 and -1 standard deviations, so around the mean. And then maybe heavy users are between 1 standard deviations and 2 standard deviations, or between 2 and 3. And then you have different buckets that are more standard to classify subscribers. We can do this based on throughput, based on latency, based on quality of experience, and based on many other metrics. This is very important because by doing this, we can actually enable completely new use cases. So these three new bubbles, quality of experience, application information, and a way to classify subscribers that is more data science way, is going to allow us to create use cases that are very different from what you have today. And they can both help you optimize your network in a major way. So what is the future of automation? We think IBCN actually makes it happen. We have a customer in Asia that actually proved this. They test our solution in their network, and one of the things they were able to do, which was very, let's say, outstanding, I would say, was they were able to maintain the quality of experience of the network and the traffic going on while they were saving traffic. 7 to 10% savings on bandwidth while maintaining the same quality of experience. This is part of what IBCN does. Balancing those resources, making sure that the applications themselves have enough resources to have a good quality of experience, and that goes beyond throughput, because uses latency and jitter and many other aspects in the network. You could still save bandwidth. So we actually provide a lot of value, and we believe we provide a lot of value. We can actually do CapEx deferral. You saw that in network optimization technologies, on congestion management technologies, in capacity planning technologies. We can at the same time have a better experience, customer experience, and we can reduce your OpEx. So the only thing we ask is let us prove it to you. Give us an opportunity to go talk to you, expand even further into these topics, and show us how much money you can spend and how you can optimize your network and make better decisions. And with that, we're finishing today's webinar. Thank you so much for attending, and have a great day. Thank you everybody for joining today's session. I hope you enjoy our presentation, and we are going to open this session now for questions if you want, and we can try to answer as many as we can live.
Yes, thank you everyone for attending, and thank you, Carlos, for that great presentation. We were able to answer a couple of those questions on the fly, so that's great. Thank you, Atif, for answering a few of those questions. Now we have a couple other ones that we got from our audience. Carlos, let's see here. We're going to take a few minutes and let's see, get to some of these questions. We may not have time to answer all of them, but we're going to get to as many as we can today. And yeah, I'll go from there. You ready, Carlos?
I'm ready.
All right, sounds good. Let's see here. All right, great question came in. Because you classify by content type, would you be able to comply with GDPR?
Yes, so the answer is yes. So one of the things that AppQoE is actually bringing to the table now, compared with like previous releases we had, is that we can not only classify traffic by application vendor, but we can group all this in content categories. So we can have categories as like video or social media, TV, you know, we have like, I think up to 14 categories. And that allow us to still apply policies that are based on like type of traffic, content type, and not be very specific and target certain companies or certain subscribers. So the idea is to group them and then comply with all the regulatory environment that you have in your own country.
Got it. Great. Another question here that we had come in. We're already doing shaping. What is the difference between what we're doing today and what Sandvine offers?
I think it's different because with AppQoE, what we are bringing is this concept of quality of experience. And before this concept was even available, right, all the policies that you could apply are based on like throughput and latency, you know, traditional metrics that you use in the network. This is going to give us another angle, right? So now we can do shaping not only based on those traditional metrics, but on quality of experience. That's what IBCM, or intent-based congestion management, is all about. Or we can also apply these groupings of like content categories, right? Now, even beyond content categories, we also have content categories and then subcategories within applications. Something that is very interesting and becoming more important is applications no longer do one thing. So it's not like Netflix only does video. It's not like Facebook only does social media, right? It's just now Facebook, you can do video, you can text with people, you can go to a marketplace. So we are able to actually identify not only the type of traffic, but also the type of traffic within the application that is going on. So imagine that opens a lot of possibilities on how to create policies around those. I don't think I can hear you, Natalie. Maybe you're a speaker.
Sorry about that, technical difficulties. So I see we're getting some questions coming in even now. And Atif is answering some of those via chat, but let's see, some of these questions that haven't been answered yet. Do you have clients on satellite market like OneWeb, Hughes? What is the feedback from them?
Yeah, we do. We actually have market. We are kind of like a very interesting company for satellite companies. So yeah, we have. I think we have. I don't know if I can say the names, but some of the ones you mentioned, we do have.
Okay. Let's see here. The real-time policies are subscriber related, e.g. changing UL, DL throughput.
Yeah, so subscriber is another dimension we can use on creating policies in real time. So if I look into, let's say, the most new use case, like intent-based congestion management, subscriber information is actually used, for instance, to detect real congestion in real time, right? Because we can classify subscribers not only as heavy users or non-heavy users like it used to be. Now we have categories like suffering users, users that are not getting even access to the radio environment. Right? So making that classification help us make policies around it, and also even internally for IBCM to detect congestion on real time. Yes, subscriber is like another angle we can use to create these type of policies.
Okay, now I see there actually were a few questions about related to deep packet inspection. One of them was, do you have your own packet inspection engine or a third-party one?
Yeah, Sunbind has their own packet inspection engine. Like we're the #1 company doing this around the world. I would say, we're leading like how we do deep packet inspection around the whole world. So yes, it's our own, and everything we do, we build it ourselves.
Yeah, that was a great question to ask and great answer. Now I'm jumping around here. How do you, I know, Atif, it looks like you already answered this. I'm not sure if the whole audience is reading the answers in the chat, but maybe Carlos, you can elaborate on how do you identify the application? Do you perform packet inspection in real time?
And that's pretty much what we do in Sunbind. So I would say there are two parts. The application detection, this is all based on machine learning, and it's been like that for like many, many years. Then you have the quality of experience part of it. We could also argue like, how do you do the quality of experience? That's based on like using the raw metrics and what we use in the network today. So those metrics like throughput and latency and jitter, all of those metrics are part of like a more complex metric called quality of experience. Right? Quality of experience is going to depend on the application you use and a combination of those metrics. My whole point in the presentation was talking about like how we use throughput because it's mainly the key one for video, but not all traffic in the network is video. So quality of experience is a more complex KPI that is trying to map all the metrics that you have in the network, and I'm talking about latency, throughput, jitter, packet loss, etc., into a metric that you can understand and is applicable for every single application type. That's also based on machine learning as well. It's kind of like we weight all those metrics based on the application type, and then we use machine learning on top to classify that type of traffic and give a score. Now, there are multiple ways to do this in machine learning. You could use it like, if I want to go into details, using decision trees or convolutional networks, that's what we do. That's basically how we generate the quality of experience.
Great. Another question that came in just now. Can you identify VPN traffic?
Yes, we can. So this is one of our categories.
Right. Let's see here. Okay. What are the typical parameters to measure or evaluate QoE? I think you already touched on some of that.
Yeah. Typical ones are the typical throughput, latency, packet loss, etc.
Mm-hmm. Do you proactively predict congestion before it happens, or once it happens, you detect it ASAP and dynamically readjust the bandwidth allocation?
Yes, so that's part of what intent-based congestion management does. We detect congestion on real time, and that's basically classifying subscribers between suffering users and non-suffering users. And the way we classify suffering versus not suffering is understanding whether they have access to the network or not. So in a typical congestion environment, let's say in a mobile network, in a congestion time, you have maybe one user using most of the capacity and then a lot of people trying to use capacity, but they don't have access. So having that classification and understanding that those subscribers are not able to send traffic through the network is what allows us to classify them like suffering users. And when that happens and you start having multiple suffering users, then you are detecting the congestion in real time and applying those policies.
Great. And then we have another question about intent-based congestion management. Is it available now? And if not, when is it available?
Yeah, it is actually available. It was released last year, and it's both for mobile networks and for fixed networks. So you can go and ask for a trial anytime. Happy to help you with that.
And I don't know, audience members, if you all saw that you can request a meeting with Carlos. There's a window next to your media player where you can also click and see Carlos's speaker bio and connect with him on LinkedIn. I don't see any other questions coming in right now. Let's see. I think that's all for today. So we actually got through all the questions. And if for some reason we missed you and weren't able to answer your question today, we will be sure to follow up with you and answer that question directly. Anything else? Any last words, Carlos?
I mean, if you guys have any other questions, please email me. I think that you have my contact information. We will be happy to help you.
Okay, great. And with that, everyone have a wonderful day, and we hope to see you at another webinar again soon.
Thank you, Natalie. Thank you guys for joining.